Welcome back to our laboratory. Well, today, by request of many of you, we will take a very good look at this thing. It is a late Soviet electronic programmable clock Electronika 2110. So, what is so special about it? So, apart from a typical time and alarm functionality, it can control up to 3 low-power devices by 16 user-defined programs. And the design of its controls gives me sort of a Star Trek vibe, if it would be on a quite tight budget. What do you think? And before we make a test run and take a look inside, a few words about our previous episode about the worst printer in the universe. Well, I have to say we very much enjoyed the festival of creativity in the comment sections, and honestly some of your comments indeed worth printing and framing on the wall. Pun intended. So many of you wondered what will happen if we actually switch that printer on. So there happens literally this. Sometimes it attempts also to move the head, but that's technically all. So eventually we gave this masterpiece of a socialistic engineering to our friend Boris, who will actually give it a good use. But there is something else, and it is quite interesting. So this morning, while digging in my shed, I absolutely accidentally found the very first Soviet jet printer called Electronika MS6312. It was produced in 1991, so a bit later than the previous one, but it looks way better. So if you want us to review it in one of our next episodes, just let us know in the comments. And now back to our hero. The clock was produced under the brand Electronika, which belonged to the Soviet Ministry of Electronic Industry, and many devices produced under this name were often re-engineered clones of Western or Japanese electronics. However, many were enough good to become quite iconic. The 21 in the model name is the idea of the Prometheus factory based in Borispol. That's a little city near Kiev where its biggest airport is located, so you might have visited it in the past. So, the clock has this VFD display with 3 information areas, and you can change brightness of this display and also turn on or off the sound signal. And below we have 3 color-coded rows matching those areas, and they refer to that or another button function depending on operation you do. So this large digit on the left refers to the channel combination. You can connect up to 3 devices to be controlled, and as you can see there are 7 combination of commands for switching them on and 1 command to switch all of them off at once. The next row defines the day of the week. There are 7 days and 1 every day option. And as the week here starts with Sunday, not Monday, as we actually normally have it here, that gives me one more reason to think that this clock, all in all, is just a clone of something. And finally, below is the numeric keyboard that allows the time input, and also there are mode selection buttons for current time, for programming, for timer. That's a clear button, and that's enter button. On the back panel there are 3 power sockets for channels marked 220 volts, 150 volt amps. But as the power to them comes from the single shared power cord, I honestly would not really risk to plug here that powerful stuff. And besides, there is a little funny historical detail about those very type of sockets. So a native corresponding plug for them looks this way, and those were often used for low voltage devices, say wired radios. So often on the back of such a radio would be explicitly written, do not plug it into the 220 volt power line. But the pitch is the same, so we could mistakenly plug it in there. Well, needless to say, that warning notice on the radio many people would read already only after it was too late. The clock itself can be partially independent from the external power, so there is a place for 2 9-volt batteries which will keep the programs in memory intact, and the clock will continue running. So let's try to make a little test run. I will use this Arduino power supply as a control device, because it has an LED which indicates its operation. So I will plug it, say, to the second channel, and then let's make it turn on by the specific time and then off after, say, 1 minute. But first I need to actually set up the current time. So first I press programming button, and then programming and clear. And that makes the clock reset, because right now it may have potentially some random values in the memory. Next, I need to press 0, and it becomes brighter, which means that all channels are now off. Then I need to select the day of the week. Let it be, I don't know, Friday. And after that, I need to enter the time in 24-hour format. Let it be, say, 17:30, which stands for 5 p.m. And then I press enter to put it into the memory. And you can expect that it will start to work right away, but it's made in a little bit interesting way. Well, I guess it varied from country to country, but we periodically had special current time signals transmitted on the radio or television back in the Soviet times. So the manual says that when you hear the last signal tone of the current time transmission, you should press this current time button, and now they will start to work. So this way you could make the time setup accurate. And now let's try to turn our power supply, say, on 1732, let it work for 1 minute and then turn it off. And let's first just test if it works at all. So I press the current time mode, here, and then I select the second channel. And as you can see, it turned on. Then I press 0 off, and here it is off. So now we can try to enter the command. So I again press the program button, and on the screen appears this message 1537, which means the memory is empty, and I can enter my command. If there would be something in the memory, pressing program would show me the closest one to the current time. So next I select the second channel, and day of the week, Friday, but could be also every day, and I enter the time, 17:32. I press enter, and now the disengage command, which is 0, Friday, 17:33. This and current time. And now let's wait. So as far as I understood, we can switch channels on according to those combinations, but off they can go only all at once, like this. So, well, we'll see. And here it is. You can turn off the sound signal, but this is actually the straightforward way how to use this device as just as an alarm clock. You just do not connect anything, but it will give you a sound signal. And now let's wait just a little bit more, so this will turn off. Now it went on. And we can hear relay click, and it is off. So this is it. We use just 2 commands, but you can store in the memory up to 16 commands. Also, there is a countdown timer functionality. Say we turn on manually our control device, and then we want to turn it off in some short time. So I press the clearance button, and then I choose 0 for the channel, then the date and the time in minutes and seconds. So let it be, I don't know, 10 seconds. Then I press this and timer, and let's see. And it doesn't work. Okay, well, to be honest, I tried a few more times following the manual, and I do not know if I'm doing something wrong or this very clock has a malfunction, but not only countdown never stops, it actually makes the current time also wrong. Well, anyway, you probably got idea how it should be. Okay, instead, let's just take a look inside. So with the sword and the fork, I disassembled it, and the upper part of casing looks this way, is constructed from such shaped plastic parts which are interconnected either with soldering iron or with glue, or both of them. So Well, at least it holds, but if something very hard to disassemble, for cleaning say. And below we have such relatively simple circuit board. So here we have a transformer power supply, this beautiful display, and here is the centerpiece, the core chip called KR1016V1. As far as I know, that's a clone of MN1435, and technically it's a programmable timer. It has also a sound signal generator, and this chip is designed specifically for clocks, and I guess this confirms that this clock is indeed a clone of something. And then there is a quartz resonator that has a frequency of 32 kHz, and it's attached to this chip and provides a stable functioning of its generator. Then there is a speaker, or let's say better to say a beeper, that has a very little amplifier on this transistor. And 3 channels of our control devices are based on these 4 logical chips. Then there are 3 cascades of 2 transistors in each, and these 3 simple relays. So basically very simple device, quite beautiful, quite reliable, but could be made better to my mind. So this is it. Don't forget to check our Patreon page, because there you will find a lot of interesting insights and use of various technologies in the Chernobyl exclusion zone in the end of the 80s. The link is in the description below. And this is it for today. I hope you like it, and see you next time. Well, actually next to the plush Enterprise it looks quite good. Meow.